Okay, so on your label here, the top left, the first thing that you should have identified is the mouth, and it is where things begin. So the food is broken down into littler pieces through the act of chewing, and enzymes that help to start breaking the food down are produced in saliva. So the next thing down, the thing that looks like it's underneath the tongue, on your diagram here are the salivary glands. Okay, so you've got salivary glands. That has amylase, an enzyme, and that enzyme is helpful in breaking down carbohydrates. There are different enzymes to break down different macronutrients. So amylase in the saliva starts to break down carbs. Okay? You have other enzymes that are produced elsewhere that break down fats and proteins. But the first ones in saliva start to break down carbohydrates. After that, you have the esophagus. That's how you say that. Okay? That's a tube that carries food down from the mouth where you've chewed it into the stomach where the next phase of digestion can commence. And it's carried down that tube by muscular contractions. So they kind of contract in a series to push the food down. So it will contract, and then it will contract a little bit further and a bit further and a bit further and a bit further, and the food gradually gets pushed down into your stomach, which is where it begins its digestive system proper. Okay? So that's called the esophagus, and peristalsis is the method of it being squeezed by muscular contractions to get down into your stomach. Next up, the big baggy part. The next thing down on the right, that big bag is your stomach. So, acid, really quite strong acid, which kills off bacteria. If the bacteria are too strong to overcome the acid, that's where food poisoning comes in. Yeah? So if you've eaten things that are too impressive even to get through hydrochloric acid, that's when you can get food poisoning. So these bugs must be pretty serious, right? So most things you eat, if they are like, slightly dubious milk, you're going to be fine. The hydrochloric acid is going to sort that out for you. If it's semi-raw chicken or backed soup or something that makes you really ill, the hydrochloric acid can't overcome that, and that's when you start to feel unwell. That's when you might get sickness, because vomiting is your stomach emptying itself. It's stuff that hasn't managed to get beyond that. So the hydrochloric acid hasn't sorted it out, the bacteria have grown, and your body needs to expel it quickly. Okay? This is where you get enzymes that start digesting protein. So the saliva produced the enzymes for carbohydrates. Now the food has got into your stomach, it can start to digest the proteins. Different enzymes have different, I don't know the best way to describe this really. Do you all know what Pac-Man looks like? Yeah. I know this is like a really random, sorry. Pac-Man with its like little triangle mouth, yeah. Enzymes are a bit like Pac-Man, they're kind of circular, but their mouths are all different shapes, so they can link on to different shaped molecules. So an enzyme that can break down carbohydrates has a different shaped mouth than an enzyme that breaks down protein, so that it can lock on to those particular molecules and use them and process them. So they can't process each other's. Does that make sense? Sort of. It will make more sense as you learn more about it. Okay, so we've got more muscular contraction going on here. This churns the food around. You've got the hydrochloric acid to help dilute things and get rid of things and sort of dissolve things. You've got these enzymes now from saliva working on carbohydrates. You've got the enzymes from your stomach, proteins, which are starting to digest the protein. And now the food is churned up, more and more of it, because it's in smaller pieces, it's got a greater surface area, so more of it can be accessed and processed. Okay. To the left, we've got the liver. So the liver filters blood. It detoxifies the blood. So what toxins do you reckon the liver might have to deal with? Alcohol. I love it. Yeah. That glass of wine, yeah. That liver is what deals with that. So all of your blood passes through the liver and your liver removes things that aren't good for you and helps to move them out of your body in a safe way. It also makes bile. That neutralises the stomach acid, because if you just had loads and loads of hydrochloric acid in your body, it could be damaging as well. So you get bile, which helps to neutralise that, and it starts to process the fat molecules. So far we've got something that has dealt with carbohydrates, the saliva. We've got an enzyme released in the stomach that starts helping to deal with the proteins, and the liver starts helping to deal with the fats. Okay? It makes them into smaller droplets, so that more of them is exposed. This whole process is about getting everything out of the food and made as small as possible so that your body can use it. So it needs to get into a littler thing. So all of these processes are about making the food tiny enough that it can be sent to the cells that need it. After the liver, we have gallbladder. So a little bit inside the liver. That's where the bile is stored. So the liver is looked after in the gallbladder, and then it sends it to the small intestine to neutralise that acid so that the food can be properly dealt with as it moves through. We have next the pancreas. So even more enzymes here to break down the proteins, fats and carbohydrates. Remember, we're trying to make everything tiny so that it can be absorbed properly into cells. Anything that isn't a protein, fat or carbohydrate is expelled as waste later on in the process. So pancreas does an awful lot of the endocrine stuff. It does a lot of the hormonal releasing. It releases some more carbohydrates to help deal with the carbohydrates, the lipase to deal with the fat enzymes, and the protease for the protein. So it's taking away and providing the small intestine with all of the stuff it needs to completely break down this food. It also releases insulin, which is what specifically metabolizes sugar. So insulin, again, as a hormone, will have a particular shaped mouth, if you like, in our Pac-Man link, that can deal with sugars. Into the small intestine, continuing with these enzymes that increase digestion, starts then to absorb the things into the blood. So everything is now little enough that it can be carried around in blood cells. So your pizza, by the time it reaches your small intestine, is now tiny molecules of carbohydrates, fats, proteins, and other stuff. The useful things have been extracted and are in your bloodstream, ready to go to where they are needed, and carries on into the large intestine. So this is where the stuff that isn't useful is then dealt with. So it's been all the way through your small intestine, it's been broken down into tiny molecules. They've been absorbed through your small intestine now into your blood. So the proteins are going off to help repair tissue, carbohydrates are going to be stored as energy, fats are going off to be stored as fats, usefully. And there's stuff left. Fibre, for example, if you've eaten loads of vegetables, the goodness and the nutrients have been absorbed now during its journey through the small intestine. You've got the waste products that are going to be left. It reabsorbs any water that's left and sends that back to the cells and leaves behind food debris, bacteria, anything else that needs to be expelled. So we talked about if you have sickness through eating something bad, that's expelled at the stomach point. If you have diarrhea, all familiar with how that works out, that's if it's gone beyond the stomach and needs expelling further through the process. Okay, so you all know how your food journey ends up, and this is the last part of the journey, and you may have labelled that similarly. So what you've ended up with through the large intestine, it has taken out water and left behind all of the waste products. So from the point at which stuff entered your mouth, it's been broken down through chewing, it's been broken down through the action of enzymes, anything valuable has been extracted and sent via the bloodstream to the places that need it, and anything unuseful or anything that is left over is now evacuated at the opposite end to your mouth. Okay?
And about the carbohydrate.
Yes, carbohydrate, yes.
Yeah, enzyme, the one. I think you said that, I think you mentioned in the screen that some kind of different one, not...
Yeah, there's carbohydrates as well, so they are released in different places.
That's why they're called different, yeah?
Yeah, yeah. And because each enzyme is going to be slightly different, and carbohydrates are all going to be slightly different, so you need different enzymes to break down different things. So sugar is a carbohydrate, but that needs insulin, which is different again, because it's a very specific shaped molecule. It needs a specific shaped enzyme to lock to it to process it.